Hello and hi everyone. So today, my groupmates and I will explain about our physics experiment, which is linear momentum. So before we start, let us introduce ourselves first.
So without further ado, we will go into our objective of the experiment. So the objective of the experiment is to study linear momentum conservation in one-dimensional collision. So the apparatus that we use for the experiment is glider flag, air track, string, weights, photo gate, pulley, meshes, and mass hanger. So the theory is the momentum is defined as P equals to mv, where m is the mass of the object and v is the velocity of the object. In any clause, one not affected by external forces and isolated system, the conservation of linear momentum can be expressed as the total momentum cannot change. Momentum before collision will equals to momentum after collision. So we can see as the figure 1 for example of the experiment to complete setup of the experiment.
Now I will show how the setup of this experiment. So the procedure start with make sure the air track is level, switch on air blower and balance the track so that the glider 2 stays in stationary position in the middle of the air track. Set up the air track system as shown in figure 1. Place the photogate 1 and photogate 2 along the track. Measure the flag length and record it. The glider 1 and place a flag on its top, a pin at its front end and 4 times 10 gram weight on each side of the glider 1. Weight and record glider 1 total mass as M1. Place an absorber at the rear end of glider 2. Weight and record glider 2 total mass as M2. Release M1 so that it will strike M2 and stick together. Record the time once the flag pass through photogate 1 as T1 and photogate 2 as T2. Detach the two glider and repeat the method 6 but use T3 and T4 for photogate 1 and photogate 2 respectively to get average value of average time. Last, take off 10 gram from each side of M1 and place on M2 and repeat procedure 6 and 7 until all additional mass on M1 transfer on M2. Now I will show the evidence of this experiment.
So, here's the result that we obtained from the experiment.
For this experiment, we will use the formula that have been given. So I will explain about the formula first. M1 is the total mass from result in the timetable, and mu is the initial velocity that we will count it after this, and plus with m2 that also we get from the timetable of the result. And u2, the amount will be 0 because it is not moving, and equal to bracket m1 plus m2, which can get in the result in the timetable, and v is a final velocity. So for the initial velocity, which represent as mu, we need to use velocity formula distance over time, and we use first time that we record. So the amount we get for the velocity is 678.11 centimeter per second. And for the final velocity also the same, using the same velocity formula, but the time we use is the second time that we record in the same trial. So the amount of final velocity is 343.70 centimeter per second. So let us try to figure out all three trials by using the formula. For the first trial,
the amount we get is 194.62 kilogram centimeter per second, and the final velocity is 163.46 kilogram centimeter per second. For trial number 2, the amount we get is 180.92 kilogram centimeter per second, and final velocity equals to 152.35 kilogram centimeter per second. For the trial number 3, the amount that we count is 167.09 kilogram centimeter per second, and the final velocity equals to 145.52 kilogram centimeter per second.
Now I will discuss about this experiment. This experiment was carried out to study the conservation of linear momentum during a one-dimensional collision. Glider 1 was released to collide with Glider 2 on an air track, and the time recorded by the photographs were used to find the velocity before and after the collision. From the result, the mass of Glider 1 is changed while the Glider 2 is remained. The first trial was recorded the time before collision 0.037 seconds and the time after collision 0.073 seconds. On the second trial, results show the time before collision 0.037 second and the time after the collision 0.072 second. The last trial showed the time before collision 0.035 second and the time after collision is 0.072 seconds.
Further, even though the value are not perfectly the same, the difference between momentum before and after collision is small. This suggests that momentum is mostly conserved. The small error may be because of friction of the air track, timing inaccuracy of the glider. Overall, the experiment supports the principle of the linear momentum conservation in one-dimensional collision.
For conclusion of this experiment is, the experiment successfully showed that linear momentum is mostly conserved in a one-dimensional collision. The gliders move together after impact and the measured value of momentum before and after collision were close with small differences caused by experimental errors. Therefore, the objective of studying momentum conservation was achieved. For reference part, we did experiment 5 linear momentum.
That's all from us. Thank you for your time and attention. I hope this video presentation has provided clear insight into our key points and the opportunities ahead. Thank you.